Hey you, do you want some code?
Welcome back. Let's create our own memory leak. How can we do this? Well, the easiest way to do it is simply create an array and declare it is empty to start off. However, within this array, we're going to create a loop. Let's say I is equal to 5. And I want you to keep looping as long as I is greater than 1. And each time let's increment I by 1. Now, you can see here that I'm creating an infinite loop because I will always be bigger than 1. So all I have to do is use the push method on the array and add I minus 1 to it. Now, when I run this code, what will happen is we'll run an infinite loop that keeps pushing I minus 1 to array repeatedly. This will continue until we'll fill up our memory and there is no more space left for us to use. Eventually, the browser will crash. Let's see how this happened once. I press enter. Alright, things are happening. Oh, did you see that? Something went wrong while displaying this web page. We just crashed our browser. Feel free to experiment with it or try creating your own memory leaks. What I did was fill up our memory heap with more and more data. The garbage collection wasn't working properly because of this array. We were using this array repeatedly until we crashed our program. So, memory leaks are pieces of memory that the application has used in the past but are no longer needed, yet have not been returned back to us to the pool of free memory. Now, this was a silly example, and most likely you're not going to do this on your programs. But there are 3 common memory leaks that happen that I want to show you, so you can avoid them in your application. The very first one, and this is something that you've heard repeatedly, is global variables. One of the reasons we don't want to have too many global variables is because when we do something like variable a equals 1, we just add in variable a as a variable in our global scope. Something we'll get into a little bit later. But hypothetically, if I keep adding variables to my environment, we are adding more and more pieces of memory. And these are objects and deeply nested objects. You can see the memory being used up more and more. Another one is event listeners. So if I have something like element equals document.getElement by ID in our browser, and let's say I select the button, and with this button I'm going to add an event listener. It's going to listen to the click event, and it's going to do some function that, well, I'll just call it on the click. We don't really have it here, but it's going to have that. Now, this one is the most common ways to leak memory, and there is by adding these event listeners and never removing them when you don't need them. So you just keep adding event listeners, and because they're just in the background, you forget about them. And the next thing you know, you create a memory leak. This happens a lot, especially if you go back and forth between single-page applications where you're not removing the event listeners from the page. As a user go back and forth, the memory keeps increasing more and more as more event listeners are added. Another common issue is simply using something like set interval, where you have to send a function that does something. And inside here, you start referencing objects. And these objects in here are going to, well, never be collected by the garbage collector, because this set interval, unless we clear it and stop it, is going to keep running and running and running. So memory leaks are something that we have to be careful of. One example is SoundCloud. You see, SoundCloud, which some of maybe you know, you can listen to some really interesting artists and music. Well, they had this application that worked on a gaming device, but it was built with JavaScript and web tools. So there is a SoundCloud application can run in the background of this game console. What they found out is that they had a memory leak because people put SoundCloud in the background. It just kept running for long periods of time. So this memory leak that they had kept increasing more and more because people would keep the application open for, well, sometimes hours and hours and hours. And they noticed that they had a memory leak in their program because unlike most websites or apps, their app runs for a really, really long time in the background. So they had to fix that memory leak. I'll leave a link to this article where they explain some of this problem. It's really, really interesting if you want to learn a little bit more about it, just something to be aware of. The memory is limited. That applies to the call stack and memory heap. Those are two places where JavaScript remembers or stores memory, and we have limited usage of them. So, for us to write efficient code, we have to be conscious of not having a stack overflow or memory leak and managing that memory well. That's enough for now. Take a break, drink some coffee, or maybe have some tea, and I'll see you in the next video. Bye bye.